Hi, I'm Anindo. I'm back again with exercise 8, activity 3. In this activity, we are trying to find clusters of 1 in a matrix which has ones and zeros. So we are allowed to move up or down or left or right by one place, and by that, as long as we don't go through any zeros, we consider that to be one cluster. We are not going diagonally. And for solving this problem, we are going to consider two different algorithms. The first one is more, I would say, more intuitive, and the second one is more elegant. And I would explain the programmatic part just for the second one. I believe the first one you would be able to do yourself. So with that, let's dive in. So let's start with the first algorithm. To explain this algorithm, let's assume a simple matrix. Let's say we have 1, 1, 0, 1, 0, 1, 0, 1, 0, and 0, 0, 0. So we have a 4 by 3 matrix. And if we look at it, it has this as part of one cluster. We wrap around, come from this side, so this is all one cluster. And since we cannot move diagonally, we have this lone one, that's another cluster. So let's see if we can find a way to identify all these different clusters. So we also define our moves that are allowed. So we can move upward, we can move downward, we can move to the right and to the left. So with that, let's see how we can go about this. So we can see these zeros are not really important. So first, I mean, they're of course important to demarcate one cluster from another, but let's first put all the positions in a single array, and we have them as 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and we go this way. So so that would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So let's first strike off all the zeros. So we have 1, 2, 3, that's a 0, 4 is a 0, 5, 6, then 7 is non-zero, 8 is 0 again, and then 9 is 0, and then we have 11 and 12, they're also zeros. So we have these as 1, 2, 5, 7, and 10. These are non-zero places, these are ones. So now we have to figure out how many clusters we have among these. So what we are going to do is we are going to start reading this position matrix from this end, and for each of them, each of the non-zero elements, we are going to apply all these different moves and see if that's going to lead us to another non-zero element. So corresponding to each non-zero element, we are going to store at the most 4 possible cases corresponding to all these 4 different moves. So if we start with 1 and let's say we go up, that means we are essentially trying to find this guy, and that's 0, so we don't care about that. Then we have we go down, we hit another 1, so that's number 2. So let's say we started with this cluster, we name it, say, cluster A. So we hit another adjacent 1 when we went down. So that's in position 2. We tag number 2 as cluster A as well. Then we go right, we hit another one, so that's essentially 1 2 3 4 number 5, and we tag that with A as well. And then we go left, we hit 9, and that's a 0, so we don't care. So then, corresponding to all these moves, we stored these non-zero numbers that we encountered. So in this case, that would be 2 and 5. So we move on to 2 and we repeat the same procedure. So we start with 2. We of course don't repeat the same move that brought us here from 1, but we try all the other moves. So we go down, that's a 0. We go to the right, that's a 0. We go to the left, that's number 8, and that's another 1. Sorry, that's number 10, and that's another 1. So we tag that with A as well. So we still have number 5. We haven't gone through that yet. So then we move to number 5 and repeat the same procedure, as in we try to do all the different moves except the one that brought us here, or rather except the inverse of that one that brought us here. So that would be, since the right one brought us here from number 1, we try the left one. We won't try the left one. So we go up, that's a 0. We go to the right, that's a 0. And we go down, that's also a 0. So we don't get any new members of the cluster A starting at 5. And then we move on to 10 because we stored that here. We reached number 10 from 2. So again we do the same thing with 10. So from we reached number 10 going left from 1, so we are not going to go right, so we exclude that one. So if we go up, that's a 0. If we go down, that's a 0. And if we go left, that's a 0 as well. So we essentially exhausted all the different non-zero elements that we could have reached, starting with any member of this cluster. So now we read up this position again and see if any non-zero element is left untagged. So if we start here, 1 2 5 all tagged except 7. So we give it a new cluster name, let's say that's B, and we start there. We follow the same procedure. We go up, down, left, right, and we see that we are hitting zeros in any direction. So it's a single member cluster, and that's it. So we essentially read up all these tags and see how many unique tags we have. And here we see we have 2 different tags, so we have 2 clusters. So that would be our first algorithm. And although it sounds complicated, I am sure you, with some few half an hour spent on this, you would be able to write this up. And I think it's time to move on to the second algorithm, which is somewhat more involved than this, but you're going to learn some important functions there that you're going to use later. For example, circ shift, and also we are going to apply functions like all and unique. So you will see that application now.